right. Happy Tuesday, everybody. Welcome to another episode of the Business Strategy Roundtable. Today, we're welcoming Todd Honeyville from Lion Inc. for a conversation about robotics. Todd, thank you so much for being here today.
Thanks very much for having me.
Looking forward to diving in the second half of our conversation today about robotics and what the future of robotics is going to might look like with all the interesting evolutions in technology today. But first, I want to explore a little bit about your entrepreneurial journey and learn how you became an expert in robotics.
Sounds good. I don't have a cat though, so I can't I can't participate. So anyway, so I went to engineering school a long time ago, in the 90s. I graduated from high school in 1990 and went to engineering school. I got a degree in electrical engineering, went on to grad school for mathematics. Wasn't into, I thought I was going to be a professor. That's why I went to grad school. I thought that would be a fun thing to do, and got really tired of school at some point and bailed on the whole thing. Got a job.
Do you mind if I interject? Forgive me for cutting you off right away, but I have two kind of related questions. What excited you about being a professor, and then what bummed you out and made you decide you were tired of school?
Well, I thought being a professor would be a good lifestyle / I also really like, I'm a fan. Academia is not the right word, because sort of academia is why I left academia. But I'm really interested. So I'm like a big puzzle guy, right? I love solving problems. So school was kind of fun for me, like especially like highly technical school, meaning mathematics specifically. I was really good at math. I loved math. I actually went to grad school because I was approached by, so I was interested in math, right? I was in engineering school. I took extra math classes. I took like just interesting, like elective math classes like graph theory and things like that. And was approached by one of my professors because in a class that I was taking that I didn't need, right? It was just like a 300 or 400 level math class that I thought was fun, right? One of the projects that I did was to like take a problem that hadn't been solved and try to solve it, right? And I solved one that we thought hadn't been solved before, and my professor like was really excited about it because it was like a new. I don't know if you know, in mathematics there are a trillion different unsolved problems. It's like kind of an infinite amount of unsolved problems there are. You think of mathematics as like kind of a fixed thing that's already done, right? It's just not. It's like once you get into the higher level math, you find out that like nobody knows anything really. Like I mean, that's not true. There's lots of good, solid stuff that we know, right? But like, especially in the like more abstract fields, they're just wide open, right? There's so many problems that haven't been solved. A lot of them aren't useful, right? There are a lot of these like esoteric problems that are good candidates for dissertations and things like that. But anyway, so I solved one of these little problems. Come to find out later that somebody had already solved it, so it wasn't like groundbreaking or anything. But my professor was like, "Oh, you should go to grad school because it's like pretty great work, and like you'd be a good fit for grad school." So they gave me a teaching assistantship, and I went to grad school, and I thought, whatever. I love college. It's a great place to spend the next X amount of time. And it was like, this might be fun to be a professor, right? Like I could just do this forever, right? Solve problems like on my own terms. But so I get into grad school, and what I went into was cryptography combinatorics, which is a pretty esoteric field of mathematics, right? It's like really like very cryptography has some great applications, but the rest of it is it's just not that applicable, right? And so I think if I would have maybe gone into applied math, I would have been happier and I might have stayed into it. But I just really didn't see like real world applications, and like solving problems for kind of no reason didn't really interest me all that much. So I decided that I wanted to go out into the real world, right? So anyway, left university, just happened to get a job at Fanuc Robotics as my first job out of college. Actually, I worked at Guitar Center for a while first, but
That's good too. That's fun too.
yeah, that was fun. But anyway, so I got a job at Fanuc just as an installation guy in like 1996 or 5 or something like that. I don't remember. Did that for a while. Learned what I could about robots at that level, right? So that was just a junior engineer at a robotics company.
What kinds of things did you guys work on there?
So, I mean, the job was installation guy. So I would go out and I went on service calls too, but basically fix robots in the field that somebody had done something to, or like reprogram something if somebody didn't know how to do it, or the installation part, which was supposed to be my primary job, was to install new systems so Fanuc had their own installation team. They have their own service guys and everything. So they would do design and build of systems around their own robots, which now as a machine builder / integrator is a little bit of a competition. They're so limited in how much work they can take on. It's not a big problem or anything. They're not a real competition because like they take what's that?
I imagine there'd be so much green space. Like there's so many things that could be made mechanical via robots that like it's almost easy not to step on each other's toes in a space competitively when there's so much green space or possibility.
Yeah, it's such a huge market. Not only that, Fanuc takes specific types of jobs. One, they'll take the jobs that are more R&D like, meaning, so for example, there's a process called bin picking. Are you familiar with that?
No, tell us what that is.
Okay, so for example, in the past, we would use a 2D camera. We still do this, but this was great technology, early technology, or the most basic pick and place operation, right? You'd fixture a part, some part comes to you somehow, right? And you need to get it somewhere else, right? Meaning like something's indexed in on a conveyor, like let's say it's a box, right? Let's do a palletizing operation. A box comes in on a conveyor, right? And you need to make a stack of them on a pallet, right, with a robot. So the easiest, most clean way to do it is to fixture the box when it comes in. So, and a box is easy on a conveyor because the box is square or whatever, rectangle, and it's rigid. And so all you have to do is let it hit the end of the conveyor and then push it to one side so it's corner justified, right? So you know exactly where the box is in space based on some origin point, right? So then when I go with the robot, I can just simply pick it because I know exactly where it is. Once I pick it, I know exactly where it is because my gripper goes to a fixed point in space, right? So all in all, and then I somehow know where the pallet is because I've done the same thing to the pallet, right? I justified it into a corner, so I know where its origin is. So all things are in known space, right? I know where everything is, exactly. And so I don't need any special fancy things to do an operation on those. I can simply just go to a known space, pick a known box, put it on a known pallet, right? And I can build a pallet. I can calculate all the positions. I don't have to guess, right? There's no guessing. So that's the simplest way to do it. The next simplest way would be, so I don't know where this thing is where I'm picking, right? So I put a camera over it, a 2D camera, and I can find it in 2D space, right? So think of a plane. Somewhere on that plane, my box exists in both X, Y, and rotational space, right? It could rotate. So the camera can return the 2D basic regular camera, right? Just same as my phone has, can return for me as long as I calibrate it so I know, that it knows what real space looks like, right? So calibration takes some image and it makes it so that there is no, skewing or any of that stuff, right? And you take the actual distance, right? So like it can measure once you've calibrated. Yeah, you understand what I'm saying?
Yes, sir.
Okay, so anyway, I can return like its XY location and its rotational angle, right? So then the robot can then recalculate its pick position based on that information and pick correctly, right? Mm-hmm. And then my palette maybe I could do the same thing if I wanted to, right? So 2D camera, that's like the next thing. We don't do that if we can help it, right? Because the first one is easier and it costs less, right? So then the second thing is picking to an unknown location in Cartesian space, or really in a plane, right? So then the third one would be full Cartesian space, meaning 3 dimensions, right? And that's called bin picking. So what happens is now, let's not use a box because a box is too easy. Let's use some random part like I don't know, coffee cup. Well, that's not good because they'd break. Apples.
Sure.
Let's pick apples, right? Maybe apples aren't good either. Something that has like, it doesn't matter, whatever it is. It comes in a bin, right? So like in a plant, you have, okay, I got a good one. So a bracket, like for example, there's a factory that I was in the other day that there's a stamping press and they're producing out from the backside of the stamping press, these brackets are falling out and they're like, I don't know, like this big, and they're like an L with a little foot on it or something like that, right? So the stamping press is just stamping and then these brackets are falling out into the bin. And this bin is like a Gaylord. Do you know what that is? Like a 48 by 48 by like, I don't know, probably like 36 bin, right? It's a metal bin. And they use these a lot in manufacturing to move parts around. So somebody then goes and forklifts, it's full. So they forklift it over to the other machine, right? Or something like that. Or maybe whatever, it goes into a warehouse, comes back out of the warehouse and they want to package them or whatever. I don't know. They want to handle them somehow. Or maybe there's a secondary operation. They want to load this part into another machine that taps holes or drills and taps holes or something. Let's say that. So I need to put it into this other machine with orientation and location, right? Like it has to fit into a fixture in this other machine so that I can drill the holes in the correct spot, right? Yeah. So it means I have to pick it with a known orientation and position, right? But it's just in this bin, like just this pile of them in a bin. So we like put a 3D camera system over it now, which this is pretty new. Now this is at the consumer level. Like Fanuc doesn't, I mean, they still do this, but like Fanuc doesn't need to do this anymore. But I guess my point is like Fanuc's or any of these big OEM manufacturers, like robot manufacturers or technology manufacturers, what they're doing, if they're doing this kind of integration, is they're living closer to this technology limit, right? So they're doing the bin picking before it rolls out to everybody else because they're actually still like making changes to their core software when they're doing it, right? So they're like, we'll quote this to somebody who needs it, and then they'll give them a deal-ish, right? And they'll also do the R&D on site with the customer kind of thing, right? And then once it's deployable, then we get it, the technology, we can implement the technology and we don't need Fanuc anymore. And they're kind of on to the next thing, right?
Yeah.
So anyway, that's one of the reasons we don't compete with them. The other reason is because like large OEMs, like let's say GM, who buy 300 robots at a shot, get all their service. right? Like whatever service they want to like focus on those big clients who are going to buy like thousands of robots a year, and uh, like almost nobody can compete with that, right? Like
Right.
there are very few integrators who are that big. So
And because they're prioritizing on the R&D type of deals, they are first with the polished technology, and then they probably license, you
well, yeah,
know.
they effectively, I mean, I'm sure they had their patents on it too, but they effectively then charge us license fees for all of those features, right? They don't just include that stuff. It's all separate pay.
Yeah.
So
Yeah.
yeah,
Well, and it's
so that's
definitely
how
not
they make money.
and it's definitely not open source.
No, 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 no. I mean, there are open source solutions, but you have to take it in, like you're taking your life in your own hands. As an integrator, we don't really use open source technology because if we did, then we're on the hook for all like issues, right? And there's nobody else. So if we buy a licensed piece of software from somebody who developed it, right, then if there's a problem, we can push back on them, and we don't have to be on the hook for something that we don't even understand barely, right?
Yeah. Yeah.
So
I've got a question here. So, when you ended up in your first role after Guitar Center being in robotics, did you have a sense that you had wanted to be in robotics when you were in school, and math, and problem solving was your jam?
no, not at all. In fact, that's nowhere near where I was headed. So my engineering degree is electrical with a focus on communications, which is like signals, so signal processing, that kind of stuff. So where I was going based on my undergraduate degree would have been telecoms, right? And then subsequently, I went to grad school for math, and then maybe that pushed me towards something more, mm, I don't know, probably like still computer based, like something like that, right? Um,
Right.
no, when I graduated, I mean, I went to work at Guitar Center because I moved to Detroit and started looking for a job and wanted to have a job in the meantime. And like, I play guitar and I'm into it. So I just got a job there while I was looking for a job. And the jobs that were available in Detroit, I was from Michigan, so I ended up in Detroit. Um, the jobs in Detroit were primarily manufacturing jobs. So it's manufacturers or suppliers of manufacturers mostly, right? Like, I mean, there's other stuff there too, for sure. But that's the big business, right? That's in there. So I went and interviewed at manufacturing, well, automotive companies, and those looked horrible to me. Like, I went into I went into a plant it was a GM plant in, I don't remember, Novi or something. I don't remember where it was. But so I go in there and the guy's like, there's one electrical engineer. So in a factory, they call them controls guys. So what you do is uh, it's electrical and programming of machines, right? That's your job. So I go in there, and this guy who is like the only guy who is a controls guy in the plant, and the plant's huge, right? It's like, I don't know, 300,000 square feet or more. I don't know. I'm making stuff up. I don't know how big it was. Big, right? Lots of lines, and it's automotive. And the way that automotive works is it's like the lines have to run, and they're really like crazy about it. Like if the line stops, which I mean, by rights, they should be, right? Because if the line stops, 300 guys are standing around doing nothing, right? And 300 guys standing around doing nothing costs a lot of money, right?
Oh
And
yeah.
then they also like add in the lost production of like, we just didn't make 6 cars because you had the line down, and 6 cars are worth another $300,000 or whatever, right? So they're all crazy people. And so I go in, I go in, and the guy's like, yeah, so this is the guy who was interviewing me. He's like giving me a plant tour, and he's like, I'm like, so how much do you work? What's the job? He's like, well, I work like 6 days a week, 12 hours a day, and like, there's no end in sight. I'm like, okay. And he's like, and basically, I have enough projects to keep 20 people busy for 100 years. Like there's no way we'll ever get the plant running correctly. And like there's always an emergency, line down emergency. I'm like, well, this sounds like a great time. Let's do that. And so anyway, I passed, right, and ended up getting a job at Fanuc. So, and that was like kind of fun, right? And it was kind of my introduction into, and that's really what I guess changed me from, because what I wanted to do was the more like paper and pencil kind of stuff, right? That's one of the things I was doing with math and like with communications, right? But then I go in and start doing like robot programming, and it's this real world thing that actually moves, right? So you make a program and the robot actually moves and performs this operation. And I'm not just limiting it to robots, because we're an automation company. That's what my company does. And it's not just robots, it's also like conveyors and moving stuff around with pneumatic cylinders, or like picking places that are maybe they're electric, but they're still not robots. They're maybe just actuators, electric actuators, or gantries, or things like that, right? So, but the thing about controls or automation specifically that's interesting is there's some rewarding thing that happens that doesn't happen in some other types of engineering, right? So you actually build or program or whatever a thing that does something in the real world. So when you finish it or deploy it, it runs, and that's really cool, right? As opposed to like a piece of software that just sits on your computer, and when you click a button, it loads another page, right? Yeah, I get people who are into that, and like there's some reward there. I get that, but from my perspective, the actual real world implications, like the things that happen in the real world, were really like pretty great. It was pretty cool. So, and I think everybody kind of thinks that way too, right? Like everybody kind of is in love with robots. So then you go to or you watch on the videos on TV, like they have those like factory tours on TV or on YouTube or whatever, right? With all the robots, and everybody's kind of enthralled with them. It's because they actually do something, right? There's something cool there. So,
well, if I could cut in for just half a second, I think the thing, and I don't know shit at all, but I think the thing that's exciting to, at least for me, about robots is it's like software doesn't reduce the workload, it speeds up the work, but then there's more work. But when you know what I mean? It's like the never ending like pile of paperwork, you know?
sure.
But when you have a robot that's functioning in the world, it's almost like you're really able to take something that you're doing and give the whole thing away. And there's some softwares that I guess do that, but there's so much that I think has to be done tertiarily around software programs. But with robotics, you're really giving away a task wholly.
Right. Well, if you look at, this is totally anecdotal. I don't remember any statistics or anything. I just know that I've seen something like this in the past. But there's some evidence that computers specifically, and like the software that goes along with it, has literally added work for everybody, right? Like instead of, and like bureaucracy is a great example of this, right? Like, I mean, instead of having to like, I don't know, I'm making stuff up, right? But instead of having to go get your wire from, John who works in the tool crib or whatever, now you have to like, like go into your computer and requisition it or whatever, and somebody else has to like approve it and blah blah blah. And maybe that stuff was going to happen on paper, but there's like this world of computer bureaucracy that's happening, right? That never existed before computers. So
Yeah.
now everybody has a job, but I don't know if it's important, right? So
Yeah, I think that's the right way to say it. And it doesn't feel rewarding.
right. Well, and I think that that's a big problem with the the world right now. I don't know if the world's maybe too big a statement, but like the Western world for sure. Like we have a whole bunch of non-rewarding work to do, right? So like and that's probably one of the reasons everybody is kind of miserable. Not everybody, but you know what I mean. There are a lot of people who are miserable, yeah. So everybody's kind of out to try to find the way that they can, make money without doing this crappy drudgery, right? So
without being miserable.
right. So, but there are rewarding jobs out there. This is kind of one of them, and that's what's sort of interesting about it, right? And it's actually real productivity, and it has some like really big world outcomes, right? So
Yes, it does. So
anyway.
you had your first role in robotics, and thank you for being willing to go down some of these kind of tangents with me and share so much. So you had your first role in robotics. Give us, since we're kind of getting close to transition, and I know lots of people are going to want to hear the bulk of the second half, because it's so interesting in terms of how our robotics going to do here in the near future. Tell us kind of briefly how you went from that first experience in robotics to saying, like, I'm going to be an entrepreneur doing it, because that's pretty freaking cool. That's kind of a jump.
Sure. So I actually had kind of sort of entrepreneurial from when I was a kid. So I started a number of little stupid businesses when I was younger, including like I started a boat washing business when I was in high school.
Smart.
Just dumb stuff. Lots of people have done stuff like this, right? But it kept going for me. Like I then when I moved out to Colorado at some point after college, and I started a landscaping company, new install, like lawns and sprinklers company for a while. I did that while I was just an engineer, right? Like I started this other business. And so I just like always had this idea that I wanted to do something, myself, right? And so I kept starting these little businesses. And in the end, basically what happened was I was working for a company and I had been outsourced to another company as a controls engineer. This is like in 2002 or 3 or something like that. So I was outsourced to another company to get their machine running, and I got their machine running. And then the owner of the company, said to me, "Hey," he liked me, like I did a good job, and he's like, "Hey, like, are you interested in doing another one? We have another machine that we want to do." And we talked about it for a little while, and I said, "Well, how about this? How about I quit my job and just do contract for you, because like I wanted to start doing my own thing, right? I wanted to be out on my own." He said, "Sure, let's do that." So I did that for like a year. So I worked for him as a contractor for a while, and then got work other places also, right? So I started spreading myself way too thin, right? Started doing effectively consulting contract work for other folks, right? Writing programs for them basically is what I was doing electrical design. And then not after that, I like started hiring people because there was enough work for everybody to get. Sorry, somebody just walked in and it totally distracted me. So anyway,
started hiring people.
Yeah, so I like started hiring people to like, because my work, there was too much work, right? So I started hiring people, and like I ended up basically with a little company that did engineering consulting work, right? So and to be honest, this isn't Lion Inc. This is a predecessor of Lion Inc. So we did that for a while, and somewhere around 2000, I think 11. So I built it up to about 5 guys in 2011, and we were doing control services basically, right? And I met some other guys who had an automation company, but were super mechanical heavy. So they had 3 owners, and then they had like 5 mechanical engineers and 1 controls guy, and there was they really couldn't keep up with their work. They were trying to find ways to outsource controls, and we'd been talking. And so what we decided was that this would be a great fit for us to merge, right? So we merged companies together. We all went to work at their facility. They had a nicer facility than we did. So we all went to work at their facility, and I became the vice president of sales. And we tripled I tripled their sales the first year I was there. Well, when I say the first year, I only stuck around for 8 months because I really ended up not liking working with a team like that. And I know you can read this however you want, but it was difficult for me to integrate into a multi-owner corporation. Okay. That's really, at the end of the day, I'm kind of the guy that has to be the guy, and it's trouble for me and it wasn't just that. So these guys were also young and really had different ideas, and they wouldn't listen to me because I was old, which is trouble. It didn't feel like that was the way it was going to go at the beginning, and then it kind of played out that way. So I really didn't have a lot of say, and I thought that I had a lot of good experience that they weren't really and yeah, maybe I'm just being an egotist or whatever, but I couldn't deal with it. So I had to leave and start another company. So I started this company in 2012. And we immediately started as a full service automation company. And we have been in business since then. So that's kind of how the evolution went. I've also done some other stuff. There have been some serially entrepreneurial stuff in the middle and ongoing too. So, but it's really sort of insignificant compared to this, right? It's just either fun stuff, or I was trying to do something that maybe I shouldn't have been doing. Well, I started a trucking company because during COVID, I was paying for trucking services right out of Lion, right? And I was like, this is stupid. I'm paying for trucking services. I can just buy a truck and truck my own stuff. And then I bought a truck and trucked my own stuff and hired a guy to drive it. And then I'm like, why am I not selling trucking services? So I started a trucking company. But then the trucking market crashed, so I stopped doing that. So anyway.
Very interesting. I hope that, I have a feeling that there may be multiple conversations that could be had over the course of the coming years about what's happening in the world of automation. I hope that if you come back sometime, that we could poke around in your entrepreneurial journey a little bit more, because
Sure.
You've done a lot of different things. And one thing that I hope to show with this portion of the podcast, the first half of each episode, is there's not a right or wrong way to become there are right or wrong ways, but there's not a right or wrong path to take to become and be an entrepreneur. And I think breaking down and digesting the different ways successful entrepreneurs have done it can really show people that are thinking about a journey, or in a journey, or in a second journey, can give great perspective on what's possible and the ways to go about it. So I hope someday we can.
I have a whole bunch of bad examples, things that maybe you shouldn't do.
Those are good ones too. The lessons learned are super valuable. Let's transition over into our official topic of the day, which is what robotics can, will, can't, and probably won't do. And forgive my goofy title there, but
Sure.
Essentially what I want to kind of break down is where robotics are now, and maybe you could talk a little bit about where it was when you got going, and kind of the variance in between 2012 and 2025, and then we'll poke around on probably won't do or will do.
Okay. Well, so actually, if you go back to the beginning of my career, or when I was a kid, even robots, when I was a kid, robots are brand new, right? There is no, there are like sci-fi shows, but in the real world, when I was a kid, there's no real robot really, right? Like 1967 or something like that is the first industrial robot, and it's kind of a piece of garbage, right?
What was it?
I can't remember the name of it. It turns into Kawasaki later. The guy, it was actually an American guy. I can't remember the name of it. It's like, feels like the name is like Automate or something like that. But it was a hydraulic robot, right? And it didn't do very much. It was like a very basic one. It was an arm, right? But it was a very basic mechanism. And he worked, I think he worked for GM and then spun off the company. But ended up selling the prototypes or whatever you want to call them. I think that they actually had a bit of a business, but anyway, sold it to Kawasaki, who developed it further. And Kawasaki is actually a real player in the robot market now. So, I mean, it has been for a long time, but anyway, so when I was a kid, there's very little robot anything, right? And then fast forward to when I started my career in the 90s, industrial robots are the real deal, right? Like, so 95, 96, when I started working at Fanuc, automotive plants are full of robots already, right? So like 30 years, and we've gone from no robots really to let's call it fully automated factories, right? They're not fully automated, meaning there are still people. And today, if you go into these factories, there are a lot of people in them still, but they're doing ancillary tasks. They're not welding, right? They're not assembling physical parts together. Like, so I worked in the body shop. Well, when I say worked, I mean I was in the body shop of an automotive. I was at Hyundai in 2006 for like a year and a half, 2005, 2006, something like that, for like a year and a half, helping start up that plant. And they had, I don't know, in the body shop, which is the part where they weld all the frames together, or they're not frames, they're the shell pieces, right? So they stamp a door, and they stamp the inside of the door, and they stamp the outside of the door, and they stamp the outside of the car, and they stamp like all the different pieces, the hood and the inside of the hood. And they have like machines that are called seamers, right? So they put the inner part of the hood and the outer part of the hood together, and then the machine it's all fixtured, right? And then the machine just like seams it, right? Some of it, they have gluers, right, that before the parts go together, and then they also have like seam welders. So like it's all automated, all the real process. In the old days, they'd hand build this stuff, right? And then they'd assembly line it, but still hand build it, right? And then eventually by the 90s, where everything is automated, we're just the operators are just making sure that like the parts are filled. And like in 2005, when we built that plant, which was a big plant, I think it was 1 million square feet, right? But the stamping stamping presses are stamping out parts in the back, and the robots are picking up the part as they come out of the stamping press and putting them on hangers or in pallets, right? Or in, big pallets. And then they go into the body shop where the robot unpicks out of the pallet and puts them on the seamers, right? And then when it's finished, the robot picks them up and puts them on another pallet, and it goes over to the main, the main buck, which is where they weld it all together, right? So there are no operations done by a human that are big operations, right? The operations done by the humans are, one, make sure the cell runs, right? Like the cell stopped. Why did the cell stop? Oh, something's amiss, right? Go fix it. And the other thing is like, oh, the little pieces, they're like these little pieces they have to introduce sometimes, right? So they like load those pieces or whatever, or they drive the cart around to make sure that the cell has the parts it needs, right? So there's still a lot of, actually, if you look at a factory today, even a fully automated factory, there are still a lot of human jobs. Like I think that I just read an article about some new auto factory where it's a fully automated factory, and it still had like 500 employees or something like that. So there's still a good contingent of jobs, right? They're just better jobs. They're not like dirty, heavy lifting jobs anymore. They're like easier jobs. So, and I don't know, I did have a little trouble with automating as a, putting people out of work for a while when I was earlier in my career. So I guess I'm talking about that a little bit, but I believe that it's justifiable. People shouldn't be doing those jobs. They're better done by robots, right? Not only because maybe robots can do a better job, because they can, right? Like arguably a robot, because of the repeatability and the precision, can do a better job than a person can. But a lot of those jobs were crap jobs anyway that people shouldn't be doing, right? Like all day long, maybe they're exposed. Like for example, a welder. There are plenty of welders still in the world, right? And there are plenty of need for a guy who welds. But for example, the weld fumes, right? Like all day long being exposed to weld fumes is a health risk, right? Whereas we make a robot do it and it's not, right? Or, for example, a palletizing operation for some thing that weighs 20 pounds or even more, right? The guy is picking it up all day long and it's a health risk, right? It's an ergonomic issue, right? He's going to be broken in 10 years or hope maybe even less, right? And a robot can do it forever. It doesn't hurt the robot. So these are jobs that should be taken away anyway.
Hey, Todd.
Yeah.
I had a connection issue that dropped me out of the call for a moment, and what I want to make sure that is possible is that I can splice and cut this back together to effectively make your point.
Okay.
Would you mind giving just one more, quick synopsis of the past, like 2.5 minutes that you went through? You started with having felt a little bit of discomfort in the early stage of your career, automating and kind of putting people out of jobs. And then you referenced how people shouldn't be doing those jobs because it's low quality work and it's hard on the humans. Would you mind, and forgive me, and it's one of the negatives of the way we produce the show at the moment, that sometimes things like that happen. But I think it's such a valuable point that I'd like to take the time to make sure that we capture it. So forgive me to anybody that is about to hear the same thing twice. And Todd, please forgive me for, the imperfect nature of this, but please make that point again for me.
Okay. Well, I just gave two brief anecdotes about that, right? So I said, like welding, for example, the fumes, if you're an all day welder every day, then the fumes are a health risk, right? So if we had a robot do that, the health risk goes away. And yet I said also there are places in the world that we can't do that, right? We have to have real welders. But in general, like that's a health risk that we can mitigate with a robot. And then I also said, if, for example, a palletizing guy, right? A guy who picks up boxes all day long and puts them on a pallet, like they come out of the machine packed, right? And he has to just stack them all day long, which I've seen these jobs, right? I've seen a lot of these jobs that we've put a robot in, and it's brutal, right? Like factory in Mississippi, for example, which we did this thing, right? So there's a factory in Mississippi where they're making plates, right? And they put 40 plates in a box, and the box weighs like 22 pounds or something like that. And so all day long, the box comes out and he picks it up like every 20 seconds or something like that. He picks up a box and puts it on a skid for 8 hours a day, no air conditioning, humid in Mississippi. And so like 100 degrees in the summer, right? And 100% humidity, and he's stacking boxes all day long. It's sort of inhuman, right? Like, so we put a robot in, and the robot doesn't care, and it just runs forever. So like, there are some really good wins in terms of like, quality of life stuff, right? So that's a reason for this stuff. I was just making the point that like, and I sort of sometimes have to just talk about how my job is justified, right? What we do is justified in the world because it does put people out of work, and people. Actually, I say that, but then in the market right now, there are just not enough operators. So it's really not putting people out of work anymore. It had in the past, it was putting people out of work. We had unemployment issues at times during my career, right? And we're still putting robots to work and not people, right? So there's a little bit of a twinge, but um, right now, like factories can't keep staff, like they just can't even fill positions. So like a robot is a no-brainer in this case, right? But anyway,
I think.
back to the topic, I guess.
Oh no, I think this is the topic though, because you're kind of describing what the robots can do now. And before we go on to what they won't and what they likely will do, I just want to make this point. We shouldn't slow down innovation and making a better world because some of the steps are uncomfortable for some people. But what we should do is, and when I say we, I mean we, the society, not like you and me are going to figure this out necessarily.
Right.
We're going to have each our own role. But what we as a society should do is identify where there are going to be problems and then and when I say problems, I mean unemployment or dissatisfaction or financial strain, and we should put scaffolding up to support those people into having another way to be valuable for the economy and for themselves, because that is the humane thing to do. And it's not necessarily, to your point, yeah, absolutely what you do is justified, because everybody, deserves a vehicle. Everybody deserves a TV, and being able to manufacture at scale is what reduces the cost of all those things. And
Yeah, that's how we
part
have them.
that's how we have them. Part of doing it at scale is reducing the cost. So if you can reduce the cost and make everything available to folks, that's wonderful. We just have to take care of the people that are being displaced.
Right.
And that's kind of what I am trying to do on some of the sides of Triunity, but to create pathways for people to learn skills and to go into doing what they actually like and want to do. And I think in a world where technology and AI and information and robotics are readily available, it comes down to what is the human interested in, and how do they want to use the tools that are at their fingertips. And I think that's a more exciting future, and I think it's also attainable. So just kind of to close your point there on kind of the job loss conversation.
Okay.
What are they not going to do, and what are they going to do? What do you think they won't do, and what do you think, like, in 5 to 10 years, what are we going to be like? Wow, robots are doing that. Like, are we going to have robots
Well,
handling cobalt mines wholly, or but do you know what I mean? Like,
so
what
there's some
they
stuff. I'm mostly in manufacturing. I'm not in mining or any of that stuff. I do see that stuff a little bit. But I mean, for example, in mining, I think that there's like a really big possibility that mining is pretty much autonomous within the next 10 years. And if you look, I actually was looking at, because I scour the web occasionally for this stuff, but like I found a like a posting where they were looking for, who Rio Tinto is? They're like one of the biggest mining companies in the world. They run like some of the big giant strip mines in Australia and stuff, and so they're giant, right? Huge. And they have, so this is kind of a interesting little side. My dad worked for a tool and die shop. He was a quality manager at a tool and die shop. This is quite a long time ago, but they were making parts for Caterpillar. And one of his things that he showed me was he had a picture, because they made some part, right, for a dump truck that in Caterpillar's lineup, right? But he showed me a picture, because Caterpillar, like they interacted a lot, right? And so he went to Caterpillar and they saw the machine that they were building part of, right, and took pictures with it and whatever. But this dump truck, like he stood next to the wheel and he didn't come to the top of the lower part of the rubber on the tire. You know what I mean?
Wow.
40, you know how on, like, they had a front end loader, which is it's the truck you drive around that's got the scoop on the front, right? that's articulated in the middle. So you know how you see those in the back part over the motor, like the engine cover, there's like this flat part in the back of the motor with the smokestack coming out. Those, like if you just go around and you see one, those are like, I don't know, 6 by 6 foot, right? Like that surface area. So the one that they were working on, 40 men could stand on.
Oh my
So
God.
these are for mining, right? So anyway, that's is sort of a side thing. I just thought it was interesting. But those guys, and this is probably 10 years ago I saw this, those guys were working on fully autonomous dump trucks at the time. So they could run the trucks down into the mine area. It was mostly for strip mining, right? But the trucks would go down the track along the mine to the bottom to get refilled and then come back up, right, to get to dump. And they were 10 years ago, they were working on fully autonomous dump trucks for that, right? So it's not a stretch to think that like those kind of things, which is really kind of an interesting, if you think about it, that's a really pretty interesting, like what the implications of that are, right? So you have a fully autonomous mining operation and you can kind of forget about it. I mean, there has to be maintenance guys and whatever, but like you can kind of forget about that. And so that means that we can implement that on Mars, let's say. I mean, there's some really interesting like long-term ramifications of that. In terms of like, but back to manufacturing, in the manufacturing world, what's going to happen is we're going to be able to automate and use robots. So robots specifically, because we do a lot of different types of automation that aren't robots also, but those will probably disappear more. Robots have become cheaper and will become cheaper, right? There's always economies of scale and what's this called? Is it Moore's law? I can't think of it. Anyway, technology gets better, costs go down, right? So robots will get cheaper, and they have gotten cheaper, right? So we'll be able to implement them in more scenarios. Technology will get better in terms of what they can accomplish. I think that they're going to take over complex tasks anytime soon is a stretch. I think that, like, for example, like Tesla's robot kind of thing, you've seen some of that stuff, I assume, it's pretty far from being able to actually do what it says it's going to do. That's just my opinion. I see videos and I'm skeptical. Complex tasks like doing the laundry is pretty far out, right? But tasks, basically what we've done over the last 20, 30 years in manufacturing is basically take the next level of tasks, right? So first we did the easiest tasks, right? The most mundane, the most repetitive, the most, the same over and over and over. And then we did the next of those, right? And then we did the next. And so we're always applying effectively the 80-20 principle, right? So it's the things that are the easiest in the mix of what's left, right? So you keep doing that forever, and you end up, at the end of the day, you end up with very little left. But the idea is we're iteratively making things better. That's kind of what's going to continue to happen, right? I don't think there's any like magic thing that's going to happen, although AI may make it faster, right? So that's the big thing that's happening right now that's new is kind of the AI thing, right? And what we've been able to do, and this has happened in inspection technology right now, so vision inspection. So we historically take a camera, like let's say there's I don't know, it doesn't matter what it is, something that you want to know if it's correct. Like we already talked about how we could locate a part using vision, but that's really like not the same thing at all. Like I don't need AI to locate a part. Maybe I need an AI to identify a part, or I need AI to identify defects in a part. So you tell me if it's good or bad. So quality is where the major application for AI is even in part not detection, identification. It's less important because generally you know what a part looks like, and so you can train a vision system without a complex AI, right? It's not that difficult. So what AI would be good for in part identification would be a machine that you don't train. You would simply just start running a new part, and potentially in the future you could use AI to figure out what to do with that part. That's kind of a long way off, right? But defect finding, quality is actually what we've been using AI for the last, it started out maybe 5 or 10 years ago with these like deep learning models, right? So they started so historically before that, what we would have to do is basically identify all defects, all possible defects, right? Any failure mode of a part. And then we'd have to write code to, say this is a defect and this isn't a defect. And what I mean by that is in a vision model, what you would do is it's still like abstracted from writing code, right? You'd basically you'd identify in an image, right? Because the image should be a fixed image. You should fixture the part so it's a fixed image. You always see the part in the same way every time. So you could like simply identify, like the person could identify the defect and then say what constitutes a defect. And what I mean by that is like, so this black area right here is a problem, right? If it's black, it's a problem. So I can say if the black is more than 20 pixels big, it's a fail, right? So I would have to identify all failure modes, and it could be generic where like any black on this part that's bigger than 20 pixels is a fail. So that's kind of a general one, but it could also be like only here, this black is here would be a problem, and white over here is a problem. So I have to identify all the different failure modes, which could be could be nearly impossible, right? So like a part, you don't even know what all the failure modes of a part are until they happen sometimes, right? So in the old days, developing this technology, you'd run the parts, you'd preemptively determine what all the failure modes you could come up with were, and then when the parts were running in real production, you would still get bad parts through the system occasionally because you hadn't identified that as a failure mode yet, right? Mm-hmm. So then the deep learning stuff started 5 or 10 years ago, and you could train the system to start recognizing new failure modes based on previous failure modes. And this has now evolved into AI, right? So it's the precursors of AI. It's the same stuff, right? It's right. Basically saying, okay, the system is now smart enough that you can just say, good part, bad part. You can like take pictures of 1,000 parts, say good part, bad part, good part, bad part, whatever, to all of them. And then the system can then extrapolate what the failure modes are, right? Yeah. And that's kind of that's kind of where we are now, which is a huge difference from the past, right? Like, yes, it wasn't really like, I mean, it's programming to some level, but it's pretty easy programming because it's sort of a 4th generation language. It's like almost not a language that you use, more visual to do this kind of programming. But, well, I say that, but then that's not all the way true. There are, to do the high-end applications, you always had to actually code. But now with AI, a much less trained individual can develop this, right? So you can push a lot of this onto the customer as an integrator. That's super beneficial for us, because if they want to add a new part, they can just add a new part, right? And the system's smart enough to figure out what to do with that, right? So or they can hire us and we can do it too, but it's much easier for us too. But that kind of thing is now happening, right? So we now have that level of AI, or I don't know, machine intelligence, right? That it can figure out from some images, it can figure out what's good and bad. Like if you have to tell it, but it can figure out, like it can extrapolate the future. I think that there's a pretty big jump that happened there, right? That could also happen in things like uh, part, pick and place operations, robots, right? So the robot uh, could now solve the problem of how to do this pick and place operation with very little input from the person, right? Like it definitely is much harder, and this hasn't happened yet, but I think that this is possible. So I think that maybe in the future, like path planning will be something that AI takes. And when I say this stuff, this is manufacturing environment, right? Like, so if you go into, they're trying to build like commercial consumer kind of robot stuff. I don't have any idea. I I'm I'm skeptical of the commercial stuff currently. I think that even with AI, there are so many problems with robots amongst people, that like safety issues and things like that, that I don't know how they're going to get over. That's going to be a long ways out, right? Things like Mars is a different story, right? You'll work with,
Or
if
even a
you're
mining, even
right.
a
Well,
mining operation, or like, which is your point about, forgive me, keep going, even
no,
Mars.
yeah, but that's what I mean. Like if there's an environment where your risk tolerance is higher,
Right.
this is more possible, right? So like, yeah, mining or like, space,
Forestry. Yeah.
yeah, stuff. Yeah, you can send stuff out, and there's yeah, right. Either there aren't people around, so you don't interact with people, or the people are well understood that it's a dangerous environment, then it's okay too. So that kind of stuff, I think there may be some neat developments that happen in those areas, right? But in terms of like household stuff, it's just I think it's a long way out. And that, I think that even with the cars, right? Like I know that they're doing some like deployment of autonomous taxis in some cities right now. Uh, but I think that we're still kind of a long way away from mass deployment of that stuff. And I mean, just snow, for example. Like I live in the Midwest, right? And there's no way that current technology can handle snow. So what do you do? you know?
Right. Well, it's
So
back.
and
It's to your point about safe environments and risk tolerance. So, like in Vegas with the autonomous vehicles, there's specific pathways where the entire section is autonomous vehicles, and that's
right,
how they've isolated the risk. They launched them in Miami. Well, how did they isolate the risk there? Well, it's your point. There's not snow. They have
right,
it's pretty reliable weather, and now reliable in that it's heavy rain and it's back and forth, but reliable in terms of what you would train the model on how to deal with, so that you can, again, to your point, have some kind of risk tolerance. I think your description of how robotics are going to evolve and how AI is going to play a role feels spot on to me. And obviously, who the hell knows, but I mean, you more than me, first of all, but in the
yeah,
grand scheme, who the hell knows? But I think when I have conversations with folks on the less robotic side, but more AI application software tools use, um, a lot of the conversations that I have are focused on creating niche solutions that leave surface area for the human to deal with the thing that you can't really train, the things that are particularly variable that require kind of handling in the moment as opposed to being trained to handle. And when you describe how robotics are utilized in manufacturing and how it may uh, come together with AI, it sounds like a similar thought process in which you you train and create a robot, or you train a model and you create a robot for a specific niche solution, not for, the Swiss Army knife of solutions, but
Right.
a tool and a robot to solve this thing that is happening. And that feels correct to me. And that also feels safest for the economy and the people in it.
Sure. Well, it's just more iterative development, right? It just is the same thing that we've always done. And maybe AI is going to give us a bump in speed, maybe, right? But it really is just iterative development. In the end, there's no like groundbreaking new like change the world thing here. It's just we're going to just keep getting better. So, and that's, I don't know, that's the way to do it safely too, right?
It's the way to do it safely from like a on the job site perspective, and I think the economy too. Because if you're iterating,
Right.
then you know where the job. You probably were making this point, but I'm gonna. You know where the jobs are going to go if you're iterating on specific things. Like if you know the next version of this tool is going to take these jobs, then the politicians and the local government and the local economic development teams and organizations, they need to see that shit and act and create solutions so that it can be a flow and not a chaotic hodgepodge.
No, actually, yeah, disruptive technology is named that for a reason, right?
Yeah.
Yeah.
Todd, this was awesome, man. I want to have you back sometime. I hope you're willing to do it.
Sure.
But for now, tell folks, give the Lion Inc. Elevator, and tell folks how to get involved with you if it makes sense. And again, thanks for being here.
Sure. So the company is Lion Inc., and we build automation systems for factories, which is hard and soft automation, robotic cells, material handling, packaging, whatever, right? Like it's a custom automation shop. Our website's www.lioninc, I can't spell, LIONINC.us. And info@lioninc.us is an email you can get us on, or 872-228-5466 is our phone number.
Awesome. Todd, thank you for being so generous with your knowledge and your time. Looking forward to continuing to get to know you and seeing what you guys do over there. And thanks to the folks that joined us today. Next week, we are taking a break week from the pod. I'm going to have a freaking birthday. So,
nice.
And then
Congratulations.
thanks, man. They keep every year they have me have one. So
yeah.
I guess we're just going to keep doing them. And then the following week, we're going to keep it going. Off the top of my head, I can't remember what it is, but hope to see folks there. And Todd, thanks again, man. This was a lot of fun.
All right. Thanks, man. Have a good one.
Bye, everybody.